Today we will be looking at 3.6, which is dealing with variation. To start it off, we will be looking at direct variation. So it states y varies directly as x. So if you see varies directly as x, then you're going to go ahead and use direct variation. Additionally, if you see directly proportional, you know that we're dealing with direct variation. So if there exists a non-zero real number k called the constant of variation, such that for all x, y is equal to kx, you're going to go ahead and have a linear function, and as x increases, y increases, and vice versa. So again, our keywords here, directly proportional or varies directly, you're going to go ahead and use the equation y is equal to kx. Now, our steps to solving a direct variation problem, we're going to have 5 of them. Our first step, determine and write the general relationship among the variables as an equation. And again, you want to go ahead and use your constant k here. Step 2, substitute given values of the variables and solve for your k. Now that you've found your k, you can go ahead and move on to step 3, which says substitute k back into the original to obtain a formula. Now, step 4, use your given information and substitute, and then finally solve for your unknown variable. Let's go ahead and look at solving a direct variation problem. So, our direct variation problem states that at a given average speed, the distance traveled by a vehicle varies directly. So, we're dealing with a direct variation problem here. Varies directly as the time. Now, if a vehicle travels at 156 miles in 3 hours, so this is our first piece of information, find the distance it will travel in 5 hours at the same average speed. So let's go ahead and look at our different steps here. Step number 1 says to write the general relationship among our variables and use constant k. So step 1, we're going to go ahead and write our general relationship, and additionally we want to use our constant k. Okay, so let's go ahead and set this up. We know that we're dealing with direct variation, so y is going to be equal to kx. Let's go ahead and figure out what y and what x represents. So if we're solving for our distance, we can go ahead and say our distance is equal to our speed times our time. So in other words, k times, in this case, we were given our hours or our time, so we know that's going to be k times time. Now, let's go ahead and move on to step number 2. Step 2 says to go ahead and substitute your values of your variables. So this is going to be using our first pieces of information here. So we have 156 and 3 hours. So our distance, 156, is going to be equal to k, or our speed, multiplied by 3. Now, we want to go ahead and solve for k here. So let's go ahead and solve for k, divide by 3, and your k is going to be equal to 52. So now that we have our k, we can go ahead and move on to step number 3. And step 3 says to substitute k back into original. So let's go ahead and write step 3, substitute k, now that we have found it, back into original. So let's go ahead and substitute it back into the original to obtain some sort of general equation. So that will give us our distance equal to k, which we now found, 52 multiplied by our time. Okay, so now we can move on to step number 4. Step 4 and step 5. We want to use our second piece of information. So substitute second piece of information. to find our unknown. So our unknown here, if we scroll back up, we want to find the distance. So we're looking for distance. It will travel in 5 hours. So since we are given 5 hours, or our time, we can just plug that back into our general formula that we had to find our distance here. So distance is going to be equal to 52 times our second piece of info, which was given to us, 5. So our final distance here is going to be equal to 260 miles. All right. Additionally, let's look at direct variation as nth power. So direct variation as nth power. Let n be a positive real number. Then what's going to happen? Y varies directly as the nth power of x. So if it tells you varies directly as, and say square of, or to the third of, then you're going to go ahead and use this type of equation here. Additionally, if it tells you directly proportional to, and it gives you some sort of nth power, you're going to want to go ahead and use this one as well. So let's go ahead and look at our equation. Y is equal to k times x raised to the n. An example of this could be the area of a square. Your area is equal to, and you'll have the same lengths here, so x times x, or a is equal to x squared. Okay, so the inverse variation as nth power. Let n be a positive real number, then y varies inversely, that's going to be a key word here, as the nth power of x, or y is inversely proportional to the nth power of x. So the equation you're going to want to go ahead and use is y is equal to k divided by x raised to the n. Now, if your n is equal to 1, then y is going to be equal to k divided by x, and x raised to the 1 is just going to be x in this case. So you're going to go ahead and use that one. And additionally, if it tells you varies inversely as x, you can use that second equation as well. So let's go ahead and look at an example solving an inverse variation problem. So in a certain manufacturing process, the cost of producing a single item varies inversely. So varies inversely, and this one gives us a power. It gives us the square of the number of items produced. If 100 items are produced, each costs $1.50. Now, let's find the cost per item if 250 items are produced. So let's go ahead and set up our steps here. So step 1, we want to go ahead and determine / write the general relationship among the variables and use the constant k. So step 1, we want to go ahead and set up / determine our general relationship. So I'll go ahead and abbreviate relationship, and then we want to go ahead and use / find our constant k. So use constant k. So this one tells us varies inversely, and it gave us a power, and that is going to be the degree of 2. So y is equal to, and it told us varies inversely, so again that k is going to be on top, and x is going to be raised to the second. So let's go ahead and figure out what our y and what our x represents. So in other words, we know that the cost per item can be equal to, so cost per item is equal to, in this case, k. We don't know what k is, but we want to solve it. And then it told us, in this case, the square of the number of items produced. So in other words, we can go ahead and take the number of items and square it. So number of items raised to the second. Okay, let's go ahead and substitute our first set of given values to find k. So substituting our first set of values, that's going to be the 100 and the cost, which is $1.50. So let's go ahead and take these values and plug them in. $1.50 is going to be equal to K, which we don't know what it is, but we want to find it. And then how many items? 100 squared. Now we can find K. 100 squared is going to give me 10,000. So I can multiply 10,000 on each side here. And that should give me a K equal to 15,000. And that step was step number 2. Okay, we can now move on to step number 3, where we substitute the value of K back into our original. So we can now take our K and plug it in right here to get our general equation. So step number 3, let's go ahead and do so. We know that our K is 15,000, and now we can figure out what our general formula is. So now we'll take 15,000 and divide it by our number of items and go ahead and square that as well. Now we can move on to step number 4, and step number 4 says to substitute our second set of values in order to find our given info that we want. So let's go ahead and combine step 4 and step 5. Let's go ahead and substitute our second set of values to find our unknown. So in this case, if we scroll back up to the top, we see that we want to go ahead and find the cost per item if 250 items are produced. Now, let's go ahead and plug this information back into our equation here. So we want to find our cost per item. So cost per item, that is now going to be equal to 15,000 divided by our number of items, and we know that our number of items for our second set is 250, and we can take that and square it. So what is that going to give us? That is going to give us a 0.24, or in other words, we could say 24 cents. Additionally, we have this thing called joint variation. Joint variation can be defined by having m and m be real numbers. Then y varies jointly as the nth power of x and mth power of z. So if for all x and y there exists a non-zero real number k, such that y is equal to k, or a constant, times x raised to the n and then z to the m, you're going to have this general formula. Now let's go ahead and look at solving a joint variation problem. Our joint variation problem states that the area of a triangle varies jointly. So again, we know that our key word here is varies jointly as the lengths of the base and the height, and a triangle with base 10 feet and height 4 feet has an area of 20 feet squared. Find the area of a triangle with base 3 and height of 8 feet. So let's go ahead and try to set this one up. First thing that we know is we're dealing with joint variation problem. So in that case, we know that our formula is going to look something along the lines of y is equal to kx and then raised to the n and then z raised to the m. So let's go ahead and write step number 1 for this one. Step 1, we want to go ahead and determine and write our general relationship of the variables using our constant of k. So step 1, we want to go ahead and figure out what that's going to be. So using the y is equal to kx raised to the n, z to the m, we know that the area of a triangle, so we could say that the area of a triangle is equal to some constant k. In this case, we actually know that it's going to be 1/2, but let's go ahead and look at this example to validate that. And then we'll have x raised to the n, or in our case, we might have b. So our n is going to be 1 in this case. And z raised to the m, again, we know that for the area of a triangle, it just has a power of m equal to 1. So in this case, h. And we can go ahead and try to figure out what our constant k is given our pieces of information. So a triangle with base 10 feet and a height of 4 feet has an area of 20 feet squared. So step number 2 says to go ahead and substitute our given values to find k. So we know that our area is equal to 20 feet. So 20 is equal to k. Let's go ahead and try to figure that out. Our base here is going to be 10 feet. So 10. And then our other piece of information was that our height was 4 feet. So the 4 is going to be right there. Now, solving this for k, we can multiply the 10 times the 4, giving us 40. So that would give us 20 equal to 40k. Then just divide by 40. So that should get you a k equal to 1/2. Okay, and that actually makes some sense because we know that the area of a triangle is equal to 1/2 the base times the height. So let's go ahead and take that k, plug it back into the equation to get us our area of a triangle. So step 3, we're going to go ahead and take that k, plug it back in. So now we have the general formula. Area is equal to 1/2 times base times height. And we can figure out our second piece of information and solve for our unknown. So step 4, let's go ahead and combine step 4 and step 5. And this should give us a is equal to 1/2. Let's go ahead and figure out what we're solving for. So we want to find the area of a triangle with base 3 and height of 8. So we want to go ahead and try to find out our a here, given the fact that we know that our other values are a 3 as well as an 8. Now, given our 3 and our 8, this should give us an area equal to 12 feet squared. Okay. So additionally, we can put all this together. So solving a combined variation problem. So a daycare supervisor has determined that the number of children enrolled in a daycare varies directly with the amount she spends on advertising. So directly with the amount she spends on advertising per week, and inversely with her weekly charge per each child. This year she spent $900 on advertising and charged $150 per child per week and had 51 children enrolled. Next year, if she spends $1,000 on advertising and charge $170 per week, how many children are expected to enroll in the daycare? Now let's go ahead and go through our steps to figure out the result for this combined variation problem. So this will give us our step number 1, which says to determine and write our general relationship of variables using our constant k. So step 1, we're going to go ahead and do this. One thing we can quickly note is we know that it varies directly with the amount she spends on advertising, and additionally inversely with the weekly charges per child. So we know that children enrollment is equal to, and again we're going to have our k on the top. Let's deal with our directly proportional part first. So let's go back up here. Varies directly with the amount she spends on advertising. So k and then amount she spends on advertising is going to be on the top. And I'm just going to go ahead and abbreviate it, advertising. What else does it tell us? It tells us inversely with her weekly charge for each child. So that's going to be what's going to be on the bottom here. So weekly charge per child. And this problem did not tell us the square or cubed, so we should be good to go with this original setup here. Now let's go ahead and move on to step number 2, which says to substitute our given values to find our k. So we want to go ahead and try to find this k given our first set of information. So step number 2, let's go ahead and try to figure out what our k is here. So our first pieces of information, what did it tell us? I'm going to go ahead and change to a different color here. So first pieces of information, 900 on advertising, 150 per child, and then finally 51 children. So given that information, we can go ahead and plug in and figure out what k is going to be. So child enrollment was 51. Our k, again, we don't know what that is, but we need to go ahead and try to solve for it. Spent on advertising, $900. And then finally, weekly charge per child is that 150. So 150 is going to be on the bottom here. Now, in order to isolate the k, we want to go ahead and multiply the 150 out from the bottom. So 150. And that should give us our k times 900 is now going to be equal to 7650. Or in other words, our k is going to be equal to 8.5. So now that we've found k, we can go ahead and move on to step number 3. So step 3, we want to take this k and plug it back into our original. So step 3, we want to go ahead and plug it back into our original. So we know that our child enrollment is going to be equal to our top, we now have 8.5 multiplied by spent on advertising, all right, and that's going to now be divided by that weekly charge per child. So weekly and then charge per child. All right, so now that we've completed step 3, we can go ahead and combine step 4 and step 5, substitute our second set of values, and then find our unknown. So let's go ahead and find our second set of values here. So our second set of values is going to go ahead and be, she spends $1,000 on advertising and charges $170 per week, and we want to figure out how many are expected to enroll here. So plugging those values in, we should have child enrollment. That is the ultimate question we want to answer. So child enrollment, and that's going to be equal to 8.5 multiplied by our amount spent on advertising was 1,000, so 1,000 here. And that's going to be divided by our weekly charge per child, which is 170. Now, figuring out what our unknown is, we can go ahead and multiply the 170. Multiply the 170. And this should give us, in this case, child enrollment times 170 is now equal to 8.5 times 1,000. And if we divide by the 170, we should get child enrollment equal to 50. So if we spent 1,000 on advertising and then our weekly charge per child was 170, given that our constant was 8.5, we should have approximately 50 children enrolled in the daycare. So this will be our final answer, and we are good to go here.